Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dokpo Jr., math instructor at the University of Liberia and your math tutor. In my today's lesson, I will be discussing differential equation. Under differential equation, I'll be looking at variable separable method type 2. So we say in type 1, if you have a differential equation and it is possible that you separate the variables on both sides of the equations, then you can apply variable separable method by integrating both sides to find your general solution or the particular solution if initial values were given. But what's about cases that it's not possible to easily separate the variables? So what you do is that you observe the differential equation for a kind of expression that you can substitute. So that expression should be an expression that is in two variables. So you want to substitute those two variables with a single variable so that at least the problem can be reducible to a separable differential equation. So this is type 2, reducible to separable differential equation or variable separable differential equation. So we want to solve an additional problem. We solved a lot of problems in previous lessons, so you can just check them up if you wish to. So in this problem now we have y over x dy by dx plus 2 times x squared plus y squared minus 1 divide x squared plus y squared plus 1 equals to 0. So our substitution is just x squared plus y squared. So we say let u equals x squared plus y squared. So we differentiate both sides with respect to x. So the derivative of u divided by derivative of x, because u is the name of the new function and y is the name of the function that we had initially. So we want to have a new function now in u and x. So we have du by dx is equals to 2x plus 2y. So we attach dy by dx since y is a function as well. So from this differential equation, we can solve for dy by dx, but dy by dx has a coefficient of y over x. So we can think of dividing all sides because x is in the denominator. So we can divide all terms by 2x. So if we divide all terms by 2x, we will have du all over 2x dx is equals, so this is just 1 plus y over x dy by dx. So we're going to have this expression. So we can solve for it now. We have du all over 2x dx minus 1 is just y over x dy by dx. So let's replace. Go to the problem. Wherever we see this one, we're going to put du over 2x dx minus 1 equals to, okay, this is not equals now, plus, you have plus 2. Now x squared plus y squared is just u, so we have u minus 1 divided by this entire expression is just u plus 1 equals to 0. Now we can find the LCD and multiply the whole thing so that we get rid of the denominators. So the LCD for 1, 2, and 3 is just 2x times u plus 1 times dx, because each of these denominators can be taken from within that LCD. So 2x dx goes into this, 2x cancel, dx cancel, you'll be left with u plus 1. So we just have u plus 1 times du minus, so this time this, so it's just the entire thing, 2x times u plus 1 dx, and then this time this u plus 1 and u plus 1 will go out. You'll be left with positive 2x times 2u minus 1 dx equals to 0. So you want to make sure that all of your terms with du on the left hand side and all of the terms with dx on the right hand side. So we have u plus 1 du. So the rest of the terms across, so we have positive 2x u plus 1 dx, and then This is negative now, negative 2x, 2u minus 1 dx. So the next thing we need to do is to see how best we can factor common expressions within, let's say, on the right hand side of this equation. So we got u plus 1 du. So if we just factor out dx is common. We can also factor out 2x. And then what will be left here is just u plus 1. And then this is minus. Now be careful with this minus. This minus must affect everything in here. So it's this time this is negative 2u. And this time this is positive 1. So we have u plus 1 du equals to 2x times, now u minus 2u is just negative u, and then plus 1 is 2 dx. So because this is dx, we only need the x expressions, so we must divide all side by minus u plus 2. We divide this side by minus u plus 2. So minus u plus 2 will carry minus u plus 2 out, and we will be left with the remaining expression. So let's quickly end the problem. So now we have on this u plus 1 all over minus. Now we can factor out this minus. It will just be positive u minus 2 du equals to 2x dx. Now the variables have been separated. We can integrate both sides. So we integrate this side and integrate this side to find the general solution. So we would now have negative the integral of u, so we can separate the numerator, u all over u minus 2 du. So this negative is as well negative the integral of 1 all over u minus 2 du equals to 2 the integral of x dx. So we continue. So we can bring in some trick. We can apply some trick right here, or you can apply long division. You divide this by this, but I don't want to go that route. So I can say u minus 2, since this is minus 2 down, u minus 2, then I say plus 2. So this will just be equals to u. So I divide this one over u minus 2, and then this one over u minus 2. You see that? So u minus 2, 2 divide u minus 2 du. The integral of 1 all over u minus 2 is just the ln of u minus 2 equals 2x squared all over 2, the integral of x. So now we can separate these two. We have the integral of, now u minus 2 is just 1, or divided by this is just 1 du. Then negative times this is negative. The integral of, now the 2 is outside. You just have the u all over u minus 2. Then minus the ln of, now u is x squared plus y squared. Then we have the minus 2. So you just left with x squared. So the integral of 1 du is just du, is just u, minus 2. This is just the ln of u minus 2, and then minus the ln of x squared plus y squared minus 2 equals to x squared plus some arbitrary constant c. But what is u? This u is x squared. So let's multiply this entire expression by negative 1 so that we get rid of this negative. So we have u plus 2 the ln of, now this u now is x squared plus y squared minus 2 minus the ln of, okay, this minus times this minus is positive, x squared plus y squared minus 2 all equals to negative x squared minus c. So that minus c will just be c. It's because it's a constant, so we're not bothered by negative or positive c. It's just c. So now this u is x squared plus y squared. Now these are like terms. So it's 2 ln of this expression plus 1 ln of the same expression is just equals to 3 the ln of x squared plus y squared minus 2, and then equals minus x squared plus, now so that minus c, now we just replace it with some arbitrary constant a. So if we send this x squared across, we're going to have, so this 3 can be the power of this expression. So I can rewrite it as x squared plus y squared minus 2 raised to the third power equals minus x squared plus a. So minus x squared and minus x squared, we can just simplify it. So it will just be 2 minus 2 x squared plus a. So I can decide to write the constant first, and then it can just be a minus 2 x squared. So this is the general solution of this differential equation using reducible to variable separable. So please don't forget to subscribe. Please do it now. Please. Thank you. See you in our next lecture.